All right. Here's the thing. Yeah, like I said before, let's try and do this with you guys. I don't want to impose my plan on this class because I find that it does not work as well as I would like it to. So it's going to be driven by your plan. Someone who has not been on screen before, someone who hasn't taken up a lot of airspace, right, other than me, should now come forward and grab the screen, and then you just have to grab the screen and have a desktop. Okay, it doesn't matter if you're just in Windows or in Mac or some other operating system command line prompt. That's fine. Just grab the desktop, get to a prompt, and then we'll take it from there. I'll show you what to do to create your very first program, and then that'll be your first program, right? Now, if you're scared to do that, chances are very high. Chances are very high that you may not get the grade you want. Not because it's not because you're being punished for not coming up here, but I'm just saying that statistically, that if you're scared to program, then programming is not the right choice for you at this time in your life, right? So anything, if you're scared to do something, you're not. If you want to be an actor and you're scared to be up on stage, you're never going to be an actor, right? So just like that, if you want to be a programmer and you're scared to cut code, and share that code with other people, because you can cut code in your basement and never ever share with the world what you've coded. Then again, it's a total waste, right? So you could be like George McFly. Is it George McFly? I don't know. This is an ancient movie, Back to the Future. Marty McFly's dad. I don't know. Yeah, I must have seen this movie a couple of times. I'm pretty sure his name was Martin McFly or George McFly. Okay, and he was a wannabe sci-fi author. Okay, so he wanted to write lots of science fiction movies and books, and he wrote a lot of them. He wrote a lot of them according to one of the scenes in the movie, anyway, if I remember it correctly. Why doesn't he become famous? Yeah, okay. He doesn't become famous because he writes a lot, but he never shows it to anyone. He never shows it to anyone. He's never out there in the public eye, and that's a bummer, really, isn't it? Because until his son comes back to the past and sets it right for him, tells him that you're a brilliant writer, but nobody's ever going to know because your books will be buried with you and they'll just be eaten up by worms. And so yeah, if and nobody knows, right? So if you have to put it out there, and I think the crippling fear, the most crippling fear I've found amongst youngsters, right? Not all youngsters. I think some youngsters who are just brought up in the wrong side of society, right? So I think that some kids get lucky, and they're brought up in a way in which they're told not to fear the opinions of others, right? Because you just need to be true to yourself. Do what you love doing, and even if it's wrong, don't worry, because but other people, I think, unfortunately, at a very young age, they get told that social opinion matters a lot. What your uncle or aunt or niece or these friends of mine think of you is a huge deal, and that message kind of filters through, even unsaid, is unspoken way. It filters through into the head of these children, and then you find many of these children being shy, right? And again, I find that the shyness, and it's an incorrect shyness, right? So you can be shy to do the wrong things, which is fine, but sometimes people get shy even to do the right things, and because they're afraid that someone will come and tell them off, or someone will have a lower opinion of themselves, of them, and all of that is just fear built into their heads by other people, right? Other people, grown-ups, maybe their parents, or maybe older relatives in their family who they've been taught to look up to, and they've kind of put that fear into their head because they themselves were afraid, right? These other older people, they're basically living in prisons. They're who is this? Yeah, some random number. Okay, all right. So they're living in prisons of their own. They're afraid to do shit. They're afraid of what other people will think of them. They're afraid of whether they're going to lose a job or other people. So they're crippled, and they're not really achieving the most they can out of their own lives. right? And I think that kind of subconsciously filters into their mindset of their children too. And these children grow up like that, and they have immense talent, right? These kids have incredible talent, but they are afraid to show it because someone might say that's wrong, and they don't have the growth mindset. Yeah, I think that's what it is, right? So Carol wrote about this whole thing in a book. Carol Dweck, right, at Stanford. She wrote about this whole mindset. I think it's called the growth mindset versus something else that she called. I don't know what she called it. Harry, so when I was at SRI, this book came out, and Harry, my neighbor, the day after it came out and it was featured on NPR, Harry came to me, stepped out of his room, and he was talking about it, and he said, what a fantastic way to formalize these things, which we've all observed, right? We've all observed it in people and in children, especially, who are trying to learn things. And somehow society, at least in the West, right, just grows children with the mindset of being, fixed mindset, and obey without asking questions, believe without asking questions, right? Believe things that are told to you. And I think that kind of works out conducively for many people. And that's not the mindset you need to have if you need to make a change in the world, right? So if you want to share happiness with everybody else, create things. You should not be afraid to create mediocre. Well, not mediocre. I don't say mediocre. It's okay to create mediocre stuff as long as you're aware that it's mediocre and needs to be polished, right, and get it to be as good as. But I think the fear that the thing that is damaging the liability, the mindset, is that it's bad to do something mediocre because people will say that's a mediocre job, even though you made it not with a view of putting something out that's mediocre, right? So I think we've narrowed it down to the exact minimal pair, right? The difference is between two people, both of who produce mediocre products, right? Both of them produce mediocre products, but the first person produced a mediocre product as a stepping stone because they know it's mediocre, but they know that, the big thing cannot be achieved until I get to the first step, which is mediocre, right? So they're there. And the second person did the mediocre job too, but instead of looking at it as just a stepping stone, they thought that was it. Oh my gosh, I did this amazing thing, right? But it's actually a mediocre thing, but they thought it was amazing because that's what they think is great, right? So, but unfortunately, for an external onlooker, these two people are exactly the same, right? So mediocre, but the person up here is actually slated to become a grand winner, right? Win the jackpot, because they don't look at the mediocre output as the final output, right? So it's a stepping stone. Whereas this person, even though they may see that great thing out there, they're never going to reach there because they have either the two things could happen, right? Either they've look at the mediocre product and said, wow, that is fantastic. I've just changed the world right now. I'm not going to do anything. My job in this world is done, right? So they probably think that and they're done. So they're not going to progress, improve anymore beyond that. Or they might think, well, I've done that, but I'm really, really scared to go up there because, I've done my bit. I can't do that. It's beyond me, right? So they could get stuck there. And so I think the best way to have that growth mindset is always go for the mediocre thing, but not with the mindset of stopping there, right? And I think that's we came up with this in the last quarter, not the last quarter, maybe last class even. I think the right mindset is to have low standards for accepting things, right? But high standards for releasing things, right? So in other words, you're happy with something that's mediocre, but you're not going to, you're not happy to release it yet, right? So you're going to keep working it and polishing it, but you're not going to feel bad about yourself, right? So that's what I mean by happy, right? So you're not going to be punishing yourself saying, oh, I did something bad, because if you're going to punish yourself for doing something mediocre, you're never going to do it. So you have to open up yourself to try something that is potentially not the best, with the view that you're going to improve that to what is eventually going to be the best. But I think most people are stuck saying, well, I'm never even going to do something mediocre. If I'm going to do something, I'm going to do that, not this. There's no way you can get there until you get here, right? But because you've set yourself in your mind to be, right, I am like the Einstein or, von Neumann of programming. I can't even imagine myself making this mediocre product, right? But this media product happens to be a stepping stone to the final product. But you, if in our elitist view of ourselves, we think, we're not going to do this, we're going to do that. Chances are you'll spend 100 years of your life just aiming for that, but never getting there because you're scared to go to the middle ground, right? So, and I think that's the reason why we have to be bold, bold. But the boldness is important. By boldness, I don't mean foolhardiness, right? So I think anyone who's past the age of, anyone who is in the late teens anyway, right? So most of you are not even teenagers now, right? Just past teenagers maybe, right? So even if you're in the late teens, I think most of us have enough sense to know when something is foolhardy, meaning that if I do that, it's not just going to make a mediocre job, but it might actually create a permanent tarnish, right, on my skill set. To the point that I cannot achieve what I want later on, right? Or maybe if I do this, I might end up with a physical handicap, right? I do something and it blows up, and my arms are blown off or something like that, right? Some horrendous chemistry experiment, electrocuted. So most of us have good sense. By the time you're a late teen, we have the experience. You've touched sufficient candle flames to know that it's spready, but it's hot. You can't touch it, right? So that means that at your age, I think you are pretty safe to take risks, right? I mean, if you shouldn't take like stupid risks, you can always ask other people too, right? If you think something is a stupid risk, you can ask other people. You ask your parents, ask your older relatives, more experienced people, saying, I want to do this. Do you think it's a good idea? But always you should also look at what they say, right? If they say, no, you shouldn't do that, period, right? That kind of thing never happens in our family, right? Those kinds of things. No, that's a stupid ass response. I don't think any intelligent parent will tell their children that. Right? So they would probably give them a good reason. Say, if you do that, then, here are the pros and cons. Here's, if you do that, that's what you are going to be setting yourself up for. Are you okay? Are you prepared to handle the backlash that might happen because of that, right? And that's basically what they're trying to do. If you're prepared to handle the backlash, I think they'll be fine. They'll say, maybe you're not prepared, but you'll get up to here. But this much and this little bit that's left, we'll help out. So you'll still be able to handle the backlash with our help. But this is something that you can still try without dying in the end, right? So, or irreversibly damaging your future, right? So you can talk and have an intelligent conversation with older and wiser people, and then you can make your decision, right? But if someone tells you don't do that just because it says so in this book, right? In this holy book, it tells you don't do this, right? You should be intelligent, mentally strong, okay, mentally strong enough to to question after the truth. Right? This is only the truth should matter. You should always ask why. If they don't have a convincing answer and they say, you have to do this, on faith, right? Then you can bring your intellectual faculty to bear and make the right reasoned choice. But I think you can't progress in programming until you start programming and share your code with other programmers. If you're shy, if you're shy, you have to get over that shyness. That's what the first 4 classes of CS2A are for. Is really not. So if you do acting, right? If you learn acting at Foothill, this is we run acting classes too. And I've done an act. I've been a student of Melissa, for example, in the past.
On that note,
can
we start coding?
Thank you, Ben. Right, so that's pull me back. Who wants to take this? Who wants to take the? But nobody has taken the screen. I want someone to take the screen. As soon as someone takes the screen,
I was just waiting to see if
I said whether I would stop. Right. Don't wait for me to stop. Right. Don't wait for me to stop. When someone takes the screen, it's a cue for me to stop. Yeah. So take the screen. Take the screen.
I just wanted to ask something real quick. Does participating in the Zoom call count towards participation,
totally.
does the Reddit post only count?
Yeah, absolutely. I think I mentioned this in a previous class. At the end of the quarter, I'm just looking for excuses to give you points. And if I don't see you on Reddit, I'll see if you are an active participant in Zoom. And if you're an active participant in Zoom, I don't have any problems giving you points. So who is this?
This
It was Susanna.
Oh, Susanna. Okay. All right. Thank you. All right. So Susanna's taking the screen.
Wait, no. Ben's taking the screen.
You did take the screen, right?
This is Ben. Ben's screen, but Susanna is talking.
Oh, I see. Okay. All right. Ben. All right. So I see that you have a bit of practice, but I want the next one who wants to line up to take a screen. I need to, someone who has not programmed before. Okay, take a screen. All right,
I
so
have not programmed
you haven't?
before. No, newbie. Yeah.
All right. So what is this? Is this an IDE or Replete? Is this Eclipse? It looks like
I believe it's called IDE, right?
Is this
It's
Eclipse?
code blocks.
Oh, it's code blocks. Okay. Oh, it's very, very similar to Eclipse. Okay. So hey Ben, for the benefit of other people, can you exit this and start from the beginning, like firing up your IDE, because many people don't even know.
I don't even know, but sure. Okay, I'll try.
All right. You know what? Let's do the very, very first program, not in an IDE. Let's just open up Notepad. Okay. So are you on a Mac or a PC?
PC. I can open a notepad.
Yeah, open a Notepad. So what Ben is going to do now is just open up a brain dead editor. It's just it's Notepad. Notepad, or it's called text edit on your Mac. Notepad.
How do I make my text bigger in Notepad?
I think you hit Control plus.
Control plus.
Oh, it doesn't work.
People can see it easier.
Yeah. Okay. What happened? How did you increase the font size?
Control plus. That's what you said.
Oh, but I thought you tried that and it didn't work.
It worked.
Yeah, okay. All right, cool. So yeah, make that half the size. That high was too big, but half the size of that would be good.
Sure.
All right, that's good. So this is a blank document. Now, do you know where this document is going to be stored? Let's store it on your desktop. So before we do anything, just save as, and save it on your, create a folder on your desktop. Create a folder on your desktop, call it experiments or something, or 2A, CS2A. Right? And then, save this as, program1.cpp. I think CPP.
What does CPP stand for?
I think it stands for C++. Okay.
Yeah, that's what I was thinking.
Yeah.
Okay.
Yeah. It's funny because I, for a very long time after starting in programming C++, my C files extensions were CC, not CPP.
So what should be the file name? Program1. You can change the TXT to CPP?
Call it ben.cpp for now.
You can actually change the TXT to CPP. Would that be a problem?
No, it shouldn't be a problem.
Really?
The only thing we need to make sure is when we save it, you save it in ASCII mode and not in rich text format mode. Because in rich text means it'll inject all kinds of formatting stuff in there. So you don't want.
So is this good?
Yeah, I mean the font is too small, but I can see it. Yeah, it looks like. What's the name? I can see the CPP.
You should do save as type all files. You should do save as type all files.
Oh yes, all files, and then say something.cpp. Right?
Otherwise, you get double extensions.
Sure, that's a good note. Thank you.
All right, now if you go to your desktop and look in that directory, that folder, you should see this file. Although it should be an empty file, you should see it. Just make sure.
Should I do that?
Everybody else, you should follow along, and you should try this too. Just make sure everything is there. These are the very first steps. Let's put all of this in the background. All right. So do you see that file, Ben?
I do see it. It has a what is it? I can show you. Let me show you. This is what it looks like in the file.
Great. And it says zero kilobytes, right? There's nothing in the file.
That's true.
Why does it have the Explorer option?
I do not know.
I think you are choosing open with Windows Explorer by default.
Yeah.
I mean,
Make that open with Notepad. Make that open with Notepad one time, and then from now on it'll. Or maybe we'll fix that later, right? You can go to the properties or options or one of those and say that always open .cpp files with Notepad, or don't worry about it now.
Sure.
Okay, so you see that file? What we're going to do here is essentially create the very first C++ program. Now
And
we're going to type in a bunch of things. And then after it's done and programmed, it's been compiled and run, you can now, we will have a discussion about, anyone can point at the program, any part of the program, and say, what's that? What's that hash sign? What's that? What, you know, you ask, and then we can basically explain every one of those things.
Totally.
Does that work?
Yes.
Okay. All right. So the first thing I'm going to type is hash mark, include, space, angle bracket, left angle, yeah, IO stream, and then close angle bracket. Okay. Next line, two, yeah, give me, one more. And you know, all these blank lines and white spaces, they're all just cosmetic details, right? So you don't have to follow it, but you may find that this is one good way to structure your code. Okay, type in using namespace std space std semicolon. Okay, all right, now punch in a couple of enters, two enters, two returns. Okay, now we want to, sounds a lot different from what Sani said something here. Sounds a lot different from what it is when you get used to it. I think it's only for Reddit posts. Oh, I see, it's a separate conversation happening here in your chat window. So I'm not gonna pay attention to that, okay? Just minimize this. So if anyone, I'm gonna minimize the chat window. If anybody wants me to look at the chat window, you have to tell me to look at it, okay? Otherwise, I'm just gonna not look at it. Okay, all right, so now type int space main, and then open and close parentheses. All right, space, and then open your curly brace, Yeah, that's fine. And then go for a couple of lines down and close the curly brace. Okay, that is your close your curly brace, and then just before the curly brace closed, type in 4 spaces and say return 0. Okay, semicolon.
Is this for the exit code, I think?
That is the exit code, yes. And that is the exit code. And what? Who said that, by the way?
Me, Chad.
Yeah.
Chad, yes, that is the exit code. And we'll talk more about exit codes later on in class, or maybe even next class. But exit
And
code.
was the first one include IO stream and that sort of stuff?
Yeah,
Is it for like a CL?
No, we'll get to that. We haven't written the program yet, right? So, but by the way, this is the bare minimum program that will actually compile and run in C++, and it's not going to do anything at all. So in fact, let's actually make sure that's what happens, right? Hey Ben, do you know how to compile programs in your this is Windows, right?
Yes. I don't know anything.
Do you have a compiler installed in your Windows machine? Do you have a compiler already installed? Do you have VS? I don't. It's such a long time since I used a Windows machine. What is a compiler? G++, right? G++ or something. Do you have a compiler installed?
Yes, I try to follow some tutorials, and then they asked me to add a bunch of stuff. So I'm 60-70% certain.
Okay, all right. So in that case, what we're going to do is right now, later on, we're all still going to install compilers. But now today, in order to expedite everything and make sure that we just have something compiled and we're able to run it, we're going to take this thing, which is good. We're going to take this and copy and paste it into an online compiler. An online compiler is essentially someone out there in the world. Yeah, I don't know where. Maybe it's in Italy. Replete, maybe it's in Italy. Maybe the domain name is in Italy, but maybe it's in San Francisco somewhere, right? So they've gone ahead and done the job, the messy part, really, installing the compiler and getting it to go. Usually is a messy part, even on Unix, right? Even on Unix, where things usually are much easier. They're paying on a Mac too, right? On a Mac where everything is supposed to be drag and drop. Even there, if you install Xcode, I've run into an issue where the Mac tells you, well, in order to get C++ to work in Xcode, you need to install the C++ module and things and extra stuff to be installed. It's a bit of a pain. So let's just go with the online compiler today, which means that someone has already installed it on their machine somewhere, right? They've gone through that job that Ben or Chad just described. They've installed it, but they are giving the whole world an opportunity to compile and run their own C++ programs on that machine that they have set up, right? So
I have an issue with my Visual Studio compiler. Can I show it to you?
no, so we're not going to do Visual Studio now. And your issues with compilers and everything, you can't discuss them in class, right? So all those things we won't discuss in class and waste class time. That should be cleared up. Compiler issues should be cleared up.
Reddit?
Even, yeah, Reddit is fine. Or you can just go to the STEM Center, right?
Cool.
Because, you know, the STEM Center folks routinely handle compiler setup, debugging issues for students every single quarter. So we have trained tutors who know how to set up VS Code, how to set up Xcode. You know, they know what's going on. But don't ask them for specific things to do with quests, or, you know, ask them to debug your code for you. Don't ask them, but, you know, get them to set up your compiler and working environment for you. Okay, so what we're going to do is in here, type Control A, Ben.
Sorry, stuck. Where should I type?
In your notepad. In your notepad, type Control A.
Control A.
Yeah. Okay. Now Control C to copy the whole thing into your clipboard.
Yes, got it.
Okay. All right. Now open a browser and go to an online compiler, right? You know, use cpp.sh or
Let me share screen.
IT or something.
Share screen. New tab. Is that right? Yeah.
Mm-hmm. Great. Just go to yeah, replete. Yeah, I think you need to hit a couple of control pluses here too.
What should I type for
cpp.sh? cpp.sh.
.sh.
Yeah, okay. So in fact, this is not the only option. If you're ever stuck with finding an online compiler, just go to Google or Bing and type in online C++ compiler. And you know, the first page of results is, you know, this is like a ton of people who've got these online compilers. You can pick any of them. Can you hit a control plus one more time? Yeah, that's great. I can see it. Thank you. All right. Yeah, I think that's, yeah. Don't go any bigger than this because, you know, your program. All right, now you can Control A here. Control A to select. Yeah, now you do a Control V to paste what you had in your clipboard. Okay, right. So this is your program that you wrote. And now, if you click the run button, what will happen is that this program will get saved on that remote machine, cpp.sh. I don't know where they're hosting it, somewhere in a different part of the world. This program is going to get saved onto the disk on some remote machine. They're going to invoke their installed compiler on this code. They'll compile it. They'll run your program on their machine. Okay, and it'll take the output your program produced on their machine and show you the output right here in this browser window. How cool is that, right? So your entire development process, well, it doesn't work for big projects, but for small projects, you know, so you've got an algorithm in your head and you want to quickly try it out and you're on a bus or a train, you can basically just whip out your phone or your iPad on your phone and basically try it out. So you don't have to get to your computer, and that'll happen, right? So you can't do big things, but you can do small things like this on a remote compiler. So it's really cool, right? You see the output. So now if you hit the run button, you'll see the output. You'll see the output right there. Okay. Now the output. Where's the output? Where's the output? Can you tell me where the output is?
No, but it's exit code 0.
No, even if the exit code is 1, you won't see the output, right? Because the exit code, you don't see the exit code. The exit code is only for the operating system that, you know, sees the exit code. If you had run the same thing on Xcode or Visual Studio, for example, it might tell you. That might tell you your program didn't produce any output, but it had an exit code of 0, right? But out there in the real world, you know, when you compile a program and run it, you don't see the exit code. The exit code is there, but you don't see it. So that blank space in here, that bottom rectangle, that's the output. And that's because we didn't produce any output. Yeah? Oh, it actually said exit code 0. Yeah, but it's not part of the output. It's in the status bar. It's in the status bar. Yeah, cool. Now return 1. Return 1 instead of return 0. Run the same thing and see what happens.
This 2 1.
Yeah, you should basically feel free to keep trying any damn thing, right? So exit code 1. So that's not the output. It's not the output. Yeah. Okay. Why is it? No, don't change it. Okay. It's really cool. Who tried this, by the way? Was it Ben?
That's me. Yeah.
Yeah. Okay. So that's a really cool experiment. That's really what we should all do, right? Anytime, you can't break it. Even if you break it, right? Even if you just did something really horrible and the computer basically just vaporized, bam, right? Everything melted down. You horrible program, not your program, right? So something happened to someone else's computer in the cloud somewhere, right? Some poor farmer in Vietnam running cpp.sh, and he went home and his computer was a blob of metal because you ran this program on it. No, but jokes aside, that's exactly what we should do. You can't break it. Try everything. Now get rid of the entire line and just type some gobbledygook. Right? Just hit the keyboard a bunch of times. Bam, 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 bam. Right? Now, yeah, hit run. You can't do anything wrong. That's the goal of this exercise is that to show you that you can't break things. You can't go wrong. So keep trying. Right? This is not even C++. And the compiler picked it up and said, yeah, error. I don't know what it is. Right? So it says, so you can do anything you want. You're not going to break anything. Okay, so return 0. Now let's make the program print something, right? How do you, you need a semicolon, right? So you need a semicolon. So there you go. So try it out, break it in as many ways as you can. Break it. You need to know. You need to know how to break things. Does not mean that you should go around breaking things, but a good programmer knows as many ways to break things as possible, right?
Really?
So if you're ever in an interview and at a top software company and they say, well, what do you know, right? Then you can say, I know how to break everything in as many different ways as possible, okay? Then you're a sure hire. They're a sure hire. I would hire you. Well, after I'm convinced. After you convince me that you know how to break everything, I will hire you. Right? Because, you need people who know how to break things, not necessarily people who go and break things. Because, if someone doesn't know how to break things, and they also don't know how to prevent someone else from breaking it, right? If you know how to break it, oh, that's how I break it. So I can do this to prevent it from breaking that way, right? So if you don't know how to break it, someone else is going to break it and you're stuck. So that's why it's very important to just keep, when you're young and you have the luxury of breaking things. When you're old, you don't have the luxury of breaking. You don't have as much of the luxury to break things. But when you're young, you have the luxury of breaking things because there are people, teachers, parents, uncles, aunts, everybody will make sure that you can break things, but safely. All right. So yeah, let us code. Hello world, let us code. Right. So if you run this now, see what happens. Okay. So so there you go. You're actually seeing Ben try things out, and he's going to fix it. I'm not going to walk him through this. You're going to try. Hey guys, did you hear a train horn just now?
Yes.
Okay, all right.
Was it from your mind or was it actually a train?
No. There was a train. Can you also hear the wind chimes then?
No.
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 Oh wow.
But I figured out how to fix my offline compiler, so I'm actually using it right now. Experiment,
You were using the offline. What do you mean?
The Visual Studio thing I talked about.
Oh yeah. Okay.
Yeah,
All
I'm
right.
just I'm trying to mess around with code like he's doing.
Who is this, by the way? Is this Ben or?
No, Chad.
Okay. All right. Cool. All right. No, we're not going to go into Visual Studio today.
Ben has a question.
But but still, it's cool. I fixed it myself.
Yeah, absolutely. Really cool.
Because then I can use it for quests and stuff.
Yeah, and also that's a very good piece of experience to keep in mind and also share with other students, because I find that many times when you get stuck with a bug, the instinctive response that many students have is immediately to go and ask, right? So either on Reddit or a friend or a parent or some brother, sister, or a STEM center and say, what's this? It's not working. And do what Chad just did, okay? It doesn't matter if you think you're not going to be able to fix it, but give it some time and think about it. You'll 99% of the time you'll fix it yourself if you just try it. Most of the time, people end up not fixing their problems because they never tried. They just think they can't do it. Okay, all right. So there you go.
Question regarding the end.
All right, sorry. Ben, speak.
So my question is, CL hello world, and then I do the left angle bracket. Do you call these angle brackets?
Yeah, angle brackets. Yeah.
And
then think about it. It's a shift operator, right? It's a shift operator.
Okay.
So you're shifting the content into cout. That's I think the semantic intent there.
I see.
Cout,
this wouldn't do an output, but then if I take away the two, the shifting thing, then this will run.
Right.
But then it will be in the same line because I don't have the and line thing.
Yes. Yeah, that's it. Yeah, experiment like that. Go ahead, do more experiments. I'm just gonna.
I don't know enough to do more. So.
No, but you don't. All right. So this is, in fact, I think we should basically checkpoint at this point, and make sure that if someone else wants to take over the screen,
Please.
and it doesn't matter, right? Do exactly the same thing that Ben did is fine too. Or you can start from scratch, or you can pick up here. Hey, click get URL. Click get URL.
Oh, so people can take
right. So you can either start with Ben's code. If you go to that URL, 4xASU, 4xASU, CPP.sh, 4xASU.
It's in the link in the chat. Sure, let me stop share.
Oh yeah, he actually shared it. So you can basically click on it, and then.
Oh, that was fun.
So what is fine?
I said that was fun.
Oh yeah, it was fun. Thank you so much. Okay, yeah. Why isn't anybody picking it up, right? Ben tried, and then he gave you a demo, and then he's shared the URL, but nobody's picked it up. Why is
I can
I
can pick it up. It's just would you prefer if I have an actual compiler? Should I use that, or should I continue using it online or Notepad?
Who is this, by the way?
This is Peter.
Peter, yeah. How about today? Just because we don't want it to be overwhelming for some of the other students, we'll just do it online, and then maybe we'll start going to the compiler, right? Maybe next class or the class after, we'll start using Visual Studio and stuff.
Okay.
Thanks. I want everyone at the end of this class to be comfortable enough to be able to write their first program, and I don't want it to be bottlenecked by the effort of having a compiler installed and going, because writing Hello World is like 1 trillion times easier than installing Xcode or VS Code.
Yeah. By the way, and this goes to anybody else, any other student also confused about downloading a compiler. If you want, Ben, I can run you through like downloading a compiler if you want, because I know it's complicated. I got really lost myself trying to get C++ done on my computer.
Hey, can I make a request, Peter?
Yeah.
So assuming that you've already got your compiler installed, and now you know all the gotchas and potential issues, can you hope ideally do it one more time from scratch? Maybe uninstall it and go through the whole process, but this time record it, and then we can post it on YouTube and Reddit. And say, if this is, I can share this with my next quarter and the subsequent quarters too.
All right. Certainly I can do that. Yeah.
Thank you.
I can work on that.
And then you can say in the description and the title, you can say, step number 1, this is how you get your compiler installed. And
cool. I'll be your first audience, Peter.
Yeah. Well, I might beat you to it, but we'll see. All right.
Yeah.
That'll be cool.
Additionally, would you want me to try because I only know how to, I've ran Eclipse for every language I've coded in. Same thing here, although it was a lengthy process to get Eclipse to run C++ for me. Should I include things for softwares I don't normally use, like IntelliJ or?
No. Just do one. Right. Yeah. So keep it as focused as possible, as unlike me as possible. Right. So keep it as focused as possible on just that one thing.
Yeah, because I know everyone has their own software,
and,
which one they devote themselves to or not.
Well, do the basic one, and then maybe next week or later you can do another IDE and say, Eclipse is slightly harder. You do it that way.
I'll think. Yeah. Okay. All right. Until then, I'll share my screen of. What's a good on the. I'll just.
And while Peter is getting the screen in the chat window, I'd like to see from every one of the students who is in class right now. I want to see a message that says, looks No, let's say, yeah, you should say, I'm confident. I'm confident that I can do this too, right? Just write the words. I'm confident that I should be able to do this, right? I can. So I'm confident that I should be able to do that too, because that's really where you need to be at the end of this class. We're not asking for, massive programs, just this thing. You should be confident enough to just do this at the end
You
of
mean to install compiler?
No compiler installs today. Compiler installations will happen after Peter posts his video, right? And then again, not in class. After Peter posts a video, we'll just say on Reddit, look at Peter's video and have the compiler installed. And in a future section, a future class, if someone asks, how do I do these compiler things? I'll just say, watch this video by Peter or Virginia or someone. Let's not waste time in class. All right. Hey, Peter, Control Plus a couple of times maybe. Are you in a different editor or is this CPP? No, this is a different editor, right? This is a different IDE?
This is a different one. I can do the other one.
No, that's fine.
Okay.
So it's important. We can do different ones so that people know there's options, right?
I just
So-
like this one because that had dark mode.
So
available.
question. So you mean that I'm confident that I could do this program?
Yes, on your own. If
Yeah.
nobody was there, or you just say if you're confident that you can.
Yes, I am. Yes, I can make Hello World myself.
All right, great. Everybody should be there, not just the ones, right? So everybody should be able to.
Yes, please, Peter. I'm gonna try to follow your demo.
I'll try and make it as understanding as possible.
This is what is it called? onlinegdb.com.
Yeah, this one. Yeah.
Okay. All right. So if anybody wants to know if cpp.sh doesn't work, because sometimes I think their servers are overloaded. I don't know. You can go to onlinegdb.com, or if this is not there, you can also go to repl.it, Replete, right? That's what the last quarter my students use, Replete. That's also pretty cool. All right. So this is Peter's code.
Debugger here too. Oh, no,
Let's see.
I do.
Now I'm gonna say let's try and take this to the next level. Let's see if I no, we don't want to do any branching statements yet. We'll save branching and looping for next class. Let's calculate a very simple expression of some kind. How about? I'm thinking of an expression to calculate some arithmetic expression which involves multiple operations, not just 2 plus 5, right? If someone else comes up with an expression like that for an interesting quantity, let me know, like pi or e, or it doesn't even have to be one of those. Golden ratio. I don't know. How do you calculate the golden? What is a golden ratio? I forgot the exact value. Yeah, does anyone have a formula for something that they would like to calculate? Formula for some arithmetic quantity. How about we just calculate the average of 15 numbers, or 5 numbers? Is that okay?
Yeah,
that's a good one. That's a good one.
All right. Okay. Good. So in your main method, just get rid of the cout hello world for now. Right now, we're going to declare. Tell the compiler that we want 5 integers. Right, 5 integers. So on the next line after main, declare 5 integers, and you would do that by saying int space. So that tells the compiler that I want integers, right? Now you're going to say int says, and call them A, B, C, D, E, because we're going to use them, right? So just call them A, B, C, D, E for now. A, comma. Oh yeah, okay, all right.
Oh, we could do.
Yeah, no. I think what we do is better. Yeah, give it a number. Give it some other people, right? Some other students call some numbers out for b int b equals
7.
Yeah.
All right, I'll go with 7, and I think I heard a 30 something.
36.
78.
6.
All right.
78.
Playing. What is a game? There's a game where people call out numbers. And you punch numbers in some card. I don't know. All right.
You need a space.
I think you
before
were
the
referring to
people?
bingo.
Yeah,
Go to.
You do not have to do any of these spaces or anything. It works just the same if I do this. It's
it
just this
works.
is
Yeah.
my own formatting because it
It
makes it
works.
easier for me to read.
But I like the way
Thank
that
you.
Peter, has formatted the code. And I would also recommend, right? Most of you who are starting out programming who may not have a style of your own just yet, rather than store code with no style, code with Peter's style, because I think he's making all the programmer kind of decisions so far, right? So in terms of laying out code, we'll also put some cosmetic tweaks in it. But
Yeah.
Spaces around operators, okay? It's important. Cosmetically, it's important. The compiler doesn't care. Important. So much so that in a modern language like Swift, right? Apple made it compulsory, right? Not only, I don't know if it's compulsory, but if you have unbalanced spaces, the Apple, Swift compiler will say, I know your code is syntactically incorrect, I won't compile it, right? So if you have no space equals, and then a space 20, yeah, if you have unbalanced spaces on both sides of the operator, Swift will say it's not correct, right? So even the cosmetics of your program is important for Swift.
Which one is the operator? Is that the equal sign?
Equals is the operator, right? And then the operands. What are the operands here? The operands are A and 0, B and 7, right? Those are the operands, and the middle is. And in this case, the equals operator is what is called a binary operator. Binary means an operator that takes two parameters, two operands, two arguments, right? So the equals takes two parameters, one on the left and one on the right, right? And the job of the equals, the function equals, is to take what is on the right and put it in what is on the left. So it's called an assignment. So the equals is called an assignment operator. It assigns the right-hand side value to the left-hand side variable. So that's assigned. So it's binary. And you will also encounter unary operators. A unary operator is an operator that only takes how many parameters? One parameter. Can someone inject a unary operator in Peter's code right here? Okay, so in this code, inject a unary operator that you know, right? That you can come up with, that you can think of, Pick up any unary operator you want. It's a simple one, right? And put it in the code and still, make it syntactically right. Can you tell me one? Who can tell me a unary operator?
An exclamation point is a not.
Oh, okay, all right. But it's yes, you are right. Who is this, by the way?
Aaron.
Aaron, yes, an exclamation mark is a not, is a unary operator. You're right, but you don't want to use it.
Does plus plus
Yeah, it
count
doesn't really
for
make sense
plus
for
one?
ints, yeah.
Plus plus is an operator too.
A unary one?
A unary one. Plus plus is a unary operator. And it has both prefix and postfix. So there's a bunch of options. So I'll pick one. Which is very simple. Okay. And you'll tell me, oh my gosh, why didn't I think of that? Okay. Because you're thinking of all the more advanced ones. But it's a very, very simple unary operator that you have all been using ever since you were in kindergarten. Okay. Probably in maybe first grade or second grade. Okay. So tell me, give me a unary operator that you have been using for at least 15 years, right? Of your life, you've been using this.
Plus.
Okay, yeah, plus is also a unary operator, but I don't know. It's very interesting. Who said plus? Was it Aaron?
That was Thomas.
Thomas, it looks like.
Thomas, hey, actually, this is very interesting. I want to try it out. Okay, so we are going to try to see if plus as a unary operator works for C++, right? Whereas it does work in our heads, right? In our heads, I can say plus 5. Plus 5 is a valid number. Plus 5, it's a positive 5. Plus 5 is a valid number, right? So in my head, it works. But I wanted to know if plus also has this additional semantic in C++ as to signal, to indicate to the compiler the number that on the right is a positive number, right? So plus, does that have that connotation? Or in C++, did the designers of C++ say, plus, oh, I'm not going to give plus two meanings. I can't allow it to be a unary operator as well as a binary operator that adds two things together, right? So maybe C++ only allows the binary operation for plus. So try to put plus in front of the 36. Try to put the plus in front of the 36 and compile it and see if it compiles, right? If it doesn't,
I think I misunderstood the question. Yeah, that won't work.
You sure it won't work?
Yes, but
On
we can try
that
it.
note,
Yeah, let's compile it and see the error message, right? I want to see, because I've never seen it. I want to see the error message.
There I guess save.
I
Oh,
think if you
go
run it,
away.
it'll save by itself. Run it. Run
Okay,
it.
I guess it's just built on its own. Let's just assume it does.
No, I don't think it compiled. Oh, you know what? It actually does. So in fact, so plus 36 is in fact a synonym for 36, right? So plus in fact is a unary operator also. Likewise minus, right? So you can say minus. Minus is the operator that I had in mind because you've been using ever since you were in kindergarten. It's a unary operator as well as a binary operator. It has two meanings in C++, right? A minus can be put in front of a variable or a constant, and it'll immediately make that a negative number. So put a negative in front of the 36 or a 7 or something like that. Okay, so now it'll compile and work too, right? So you just compile and run it, it'll work, right? So it compiled. It didn't complain. That's what I mean, right? It didn't complain, meaning it's syntactically correct. Now go ahead. Let's do a calculation, right? Say C out sum equals C out double less than shift, right? Left shift, right? Sum equals within quotes, within double quotes, within double quotes.
Sum equals?
Sum, S-U-M, sum.
Oh.
Equals, yeah, okay, and then space, and then another shift operator right there, left shift right there, okay, space. Now you want to say A plus B plus C plus D plus E, right there.
Yeah, you can, it would run like that. I'm gonna.
Yes, that's fine. You know, sometimes even though we tell ourselves in our minds that we always have spaces on either side of an operator, as programmers, we always have to be in our mind, we have to be ready to break rules, right? Like, for example, take this rule. I should always have one space on either side of an operator. That might be a very good cosmetic rule, but also have it in your mind to constantly keep asking yourself, right, the rule has served me great in all these instances, and it's probably going to serve me great there too, but is it the right rule to use this at this location? And you may find in certain situations, right, you may find, oh, here, I don't know, maybe I need the things to be more tightly bunched up together so that it looks like one thing, right? So sometimes you may make conscious judgments to say, here I'm not going to use a space, there I'll use all those things. You'll decide on your own based on your taste. Okay, so all right.
I argue that if I'm gonna write code or math especially that I'm not planning on looking at later, that I'm planning on just letting the machine run, which is very rare considering the fact that I'm not expecting my math to be perfect first try. So if I need to go back and change that, that's gonna be messy. It's really only if I'm very confident in the math that I'm doing, and B, I'm very confident that I will not need to look at this again.
Yeah.
And it's something that's just going to be big and blocky for me to not want to read. And I just want the machine to take care of without me looking at it.
Yeah. I hope everybody listened to what Peter just said. But fortunately, it's being recorded. This is all being recorded. Yeah. What he just said is very important, I think, because maybe not so important right now in your for the beginners, but as you get more and more experienced in coding, you will be. These are exactly the considerations, like Peter had now, that you'll be weighing in your own head, saying, "Oh, is this the right thing to do here?"
Nothing's worse than having to go through someone else's code that doesn't have any comments and everything's the syntax is just all around the place, where they have spaces on one line, no spaces on the other one's bunched up, the other one's like properly spaced out. It's just a nightmare.
Just being consistent helps greatly. But then again, it's something that you have, is each person has their own style. Even though, right, I can assure you, even though you say, well, I don't have my own style, I'm just going to follow Kernighan and Ritchie, KNR style or Peter's style or something, just pick some style and do it. After a few years, it'll change, right? So you'll have your own style after a while. All right, now, so before we run it, this will not work. I want to make sure, right? So it's important to try this. It's not going to work, and I'm just trying to think in my mind whether it's worth making it fail so that I can explain why it failed, or just bypass it. I can tell you what to do so that it doesn't fail, so we never even encounter the failure. Because the failure message you'll get now will probably take me a minute to explain why you're getting. Run it. Okay. It won't compile. It won't compile. And then I can tell you why. I'll tell you how to fix it.
Oh.
Boy, yeah, it actually did work.
What
Well,
was
I
the
was-
I
problem
was
that you
expecting
thought about?
parentheses on the A plus B plus C.
Yeah, me too, totally. Who said that, by the way?
Oh,
Aaron.
Aaron, yeah, I was totally expecting parentheses there too, because without the parentheses, I was expecting the precedence of the operators. So here, by
I
the end
think
of
this
this,
might fail on mine. I'm gonna try it on mine too.
yeah.
I was
Let's see
expecting
if
it to
it
fail.
runs on my
Totally
computer.
expecting it to fail, right? Because the precedence of, or you can just go to Wikipedia and look up, or Google and look up the relative precedence of the left shift operator and the plus operator. So the reason, by the end of this week, you would all be completely familiar with what is called the PEMDAS rule. The PEMDAS rule was taught to you by your third grade teacher, right? Many years ago, when you were in third grade, your teacher taught you what is called the PEMDAS rule. Does anyone know what the expansion for PEMDAS is?
Yes.
What is it?
Parentheses, exponent, multiplication, division, addition, subtraction.
Ran fine
Okay.
for me, by the way, on my compiler. So I don't.
And what is PEMDAS actually? What is the mnemonic? What does PEMDAS stand for young kids? How do they remember it?
Oh, can I say it?
Yeah, go for it.
Please excuse my dear Aunt Sally.
Yeah, okay, all right. So did everybody hear that? Was that
Never
Chad? Who said that? Chad?
Yes.
Yeah, I'm getting better at recognizing voices now.
Can you write that in the chat? Oh, perfect. I see it in the comment.
There you go. Yeah, he's actually typing it out. Please excuse my dear Aunt Sally. So that's the order.
Not gonna lie, I'll probably just turn these into my notes.
And why is that important? Why is that important? So I'm going to.
I think do computers do it in that way?
Hmm?
Do computers solve the problem in that way?
Not only computers, right? It's not only for computers. It's important to disambiguate my intent as a programmer. So type out, for example, so I'm going to say something here. Just type it out, right? So let's say int x equals, so on the next line, right? Int x equals, type in u plus v star w, u plus v star w plus x, u plus v star w plus x. No parentheses, no parentheses.
Okay, u plus v star w times. Wait.
Star w plus x, u plus v star w plus x. Yeah. Okay.
Okay,
So,
that's what you're looking for.
yeah, and then get rid of the and let's do one more thing, right? Get rid of the spaces around the pluses only, but not the times, just the pluses only.
I think,
No.
does the computer do it in reverse actually?
Hmm?
I think I figured it out. For
Yeah.
PEMDAS.
Right.
So does it, like, for example, add these things first and then that multiplies them?
No, here it doesn't do it that way. And the reason we wrote it out in this particular way is that this is what I would say is dangerous programming, right? And something that we should all try to avoid. Dangerous because the visual appearance, the appearance of the program tells us something that is completely different from what actually happens. PEMDAS rule says multiplication always happens before addition, yes?
Yes.
Okay, so when I look at that expression, int x equals u plus v times w plus x, in my mind, u plus v is close together, bunched up, right? The programmer, that is the programmer's intent that I see. So I'm going to do u plus v, I'm going to do w plus x, and then I'm going to multiply the two together. That's what it looks like to me, because that's the way it's laid out visually. Yes?
Yeah.
But the compiler will see it as, I got to do the multiplication first. So the compiler is going to do v times w first, because that's what PEMDAS says. So what the compiler ends up calculating is u plus v times w plus x. Does that make sense?
Yes.
So what the compiler sees is something completely different from what humans see.
I know it's a problem with this code also.
Mm-hmm.
There are no ints declared, u, v, w, and x.
Yeah.
Mm-hmm.
That's right. But
So it won't compile anymore unless you get rid of it.
it doesn't matter. No, this is just an example. We're going to get rid of the line. Get rid of the line. We're not going to, right? We put the line there just to demonstrate what the issue is.
Yeah.
Right?
I mean, I was hoping to keep the line, but all good.
Here, I got it. I'll just do a
A, B, C, D. Yeah. Just
Yeah.
A times, yeah.
Perfect.
And then,
Thank you.
And here, I'll even set it up.
yeah, okay. All right, and then you can put a comment saying this is comment saying misleading expression, misleading expression, right there on the line, Yeah, you can say misleading. You can also put the comment on the right side of the expression, right? So on the same on line 26, you can put the whole thing on.
Yeah.
Because I think students haven't seen that before, right? So misleading expression because the visual presentation is at odds with the computational sequence. Yeah, visual presentation is at odds with the computational sequence of operations. And it's dangerous. It's not just wrong, it's dangerous because if you inadvertently, right? I don't know. I could tell you 100 things that are dangerous, right? And people have done that to me too, right? People have told me when I was learning, people have told me that's dangerous, don't do it, right? And I say, yeah, okay, it's dangerous. But then I never know really how dangerous it is until I actually get bitten once. And that is I don't know if it's a sad truth or not, but certainly that is the truth. You have to get bitten. And the reason I say it's dangerous is because it's insidious. The least dangerous bugs in your program, as you write more and more programs, the best bugs to have, you should pray that you get bugs like that, are the bugs that are syntax errors, right? Your program doesn't even compile. The compiler can pick it up for you and say, that's wrong, not going to work. I'm not going to, right? Those are the best bugs you can have. The second best bugs you can have, not so good, are bugs that get through the compiler, but are wrong. The logic is wrong, and then you can figure it out, right? The worst kinds of bugs are also the most dangerous bugs are, they squeak through the compiler, and the logic is wrong, doesn't work, and also it's very hard to find out where it is wrong because the logic in your code is is kind of buried. It's like this misleading code. The code tells you that the logic is right, but the logic is not wrong. So that's misleading code. Misleading code is dangerous because it's like thin ice. You go skating on a rink on thin ice. It's misleading, right? You think it's like 10 inches thick, but it's only 1 inch thick. You fall into the water, right? So misleading code is to be avoided. And we'll come across one more situation like this later on when you're dealing with branching statements. There's something called a dangling else. Dangling else, that's also highly misleading. I mean, people, I've seen programmers look at code. I've been in the position myself, right? I look at code. I'm pretty sure I've looked at the code like 100 times, and I don't see anything wrong. But there is a wrong because of a dangling else. There's a mistake. This is dangling else, and I miss it because it's not visually presented. So, yeah.
I have a question.
Go
ahead.
Go ahead.
Sorry. There were a couple of questions.
Sure.
First was the double right pointy brackets, the greater than signs.
Yeah.
Why do we use, when do we put those in?
Yes,
Good
okay.
question.
So that is called the shift. It's the same as a shift operator, isn't it? So it is an operator, just like plus and minus and everything else. It's an operator that has been defined for you by the C++ programmers and is tied. That operator is actually tied to a function that they have already written for you. It's there in the library. So when you go up to the at the top of the program, you see this thing called IOStream, hash include IOStream, right at the top of your program, line 1 or so. Yeah. The hash include IOStream. That is a header file in which you'll find declarations of many of these functions, including the less than operator, right? This is the operator that tells what this does is basically just like, 5 plus 7 takes the 5 and the 7, adds the 2 together and gives you 12, right? This operator will take the C out and then whatever's on this side, and then it'll take that and put it inside of the C out. That's essentially what it's doing. So that functionality has been built in for you already. C out stands for console output, right? That's why it's called C out. So console output. There is a corresponding statement called console in. This is a read from the keyboard or right to the screen. So the console is your keyboard and screen. So C out and C in stand for console out and console in. Does that make sense? Okay.
Yes, it does make sense. And think of it like a Python print and input.
Yeah, exactly. Hey, Peter, how can you do this? How do you do these things? Is this
I'm annotating right now. I believe. I don't know how the settings are set up. I believe anyone can annotate like this.
oh, I see. No, this is not an online GDB. You're annotating in Zoom.
Yeah, I'm annotating through Zoom. I
Oh,
was
I
thinking
see.
about how to do that, and then yeah, I decided Zoom would be the best.
Yeah, cool. Hey, this is really nice. Really nice. Really nice.
Just a quick question.
Yeah.
Oh yeah, where was the place
The
where
example.
you
Go
had the pandas, and then you had only one. This, I guess, how do you even call this? You had the other one. Yeah, it's right here. Well,
So if you're wondering about
tell me the logic of it.
Yeah, so this is a group comment. So instead of, if you see here, that's a single line comment, which means that if I were to, for instance, not take this away, even though that this continues the sentence logically without another double slash, it's going to think that it's part of the code. As you see, it formats the for.
Give an error in that case.
Yeah, it's not going to know what written for compiler alone means. But what this does is essentially means that I don't need to write a double backslash every time I'm going to make an enter. So technically, and if it makes it more sense to not see my formatting, I can write that. That's going to be a part of the comment. Anything between this thing, which is my opening, think about it like a parentheses. Anything between this thing, my opening group comment, I don't actually know what it's called, and then my closing group comment is going to be considered a comment. So, which includes code. So if I forget to close it, everything's going to turn into a comment.
Can you clear your Zoom?
Yeah. I realized I was getting in the way.
Thank you.
Hey, what is that? Yeah, I didn't. Oh, that's what you want. Yeah, but yeah, I think at some point you should also annotate somewhere. Maybe because we're going to be posting it on YouTube, the annotation might be helpful.
I'll annotate what you talk about and just in general, just to
visualize
what I'm thinking about. For the video I think you're creating for right now, obviously it tends to get in the way if I scroll at all. So
yeah, that's fine.
And then if, as you saw it, because it's in a grouped, most compilers will do this, my compiler does at least, is that when I signal that it's going to be a group comment, it also allows me to close the group comment, so that way it's just going to be.
That's cool.
Like that.
Yeah, I think that form of comment is called a block comment because you can have a block, and then the other form of comment is called an inline comment, where basically it's one line. It's in line with existing code.
Are these necessary?
No, as you saw, I could delete them, and I can have any type of format I want. Anything within these blocks is going to still be considered a comment. I do that just for formatting.
Yeah.
Thank you. Perfect.
In fact, hey, Peter, can you turn your comment on line 30 into a block comment, but not on a new line? Just to show you. Yeah, you can turn.
Oh, yeah, I can do that.
Line 30, the next line. And then, yeah, he's going to turn that into a block comment right there. No, yeah, there. There you go. You see, now that's also a comment.
Yeah.
I see.
I can stop it mid-line as well, because if I type over here now, I think.
That'll be code.
Yeah, see, it's going to think everything here is a code.
But you can't do that with the other comment.
Yeah.
Does that
I see.
It's going to be a comment.
Thank you.
Right. This was a very good digression. Thank you, Peter.
So have you got to that point? Why do we include IOStream in the beginning of the code?
Oh yes. So IOStream has these the library functions already built in for you, so you don't have to write the nitty-gritty details of actually taking stuff and putting it on screen and so on. You just say send this to console out, and then the library will take care of sending it to.
Oh, now I get what IOStream is. It's the print functions, right?
No. IOStream is not the print function.
It's a lot of functions.
I mean, not just that. I just meant like one of them.
What one of the functions you need, it happens to be declared in a library, defined in a library, and declared in that IOStream file. All you need to tell the compiler is that, there is this function in the library somewhere, and IOStream, the header file, is what does that. The header file tells the compiler, when you see this word called cout, don't freak out, right? Because there is a library in there in C++ that knows what cout is. Just assume that this is what cout does. Cout.
And what does namespace mean?
Right. So namespace, I don't know if we should, do you want me to talk about namespace? Because we've talked about this in the previous video. Hey guys, you guys, did you see the videos from the previous quarter? Or you're here cold.
No,
so,
I have never seen them yet.
Well, so yeah, everybody.
But you can give me a simple explanation if you wish.
Yeah. What was this? What was this for? What was the question?
What is using namespace std for?
Right. Okay. So here's a very quick one-liner explanation, but you should see the video, right? So because we've talked about this like 100 times before, I think. So when you declare variables like x, if they are local variables inside of braces, then it's okay. Peter could be developing some program with Susanna, right? They're both developing the same program. Now, if both of them use the same name for the variable, and the variables are global, then the program won't work, right? Because Peter is using x and he's assigning it to some value, and Susanna is using the same variable x, assigning a different value, and they're doing their own logic. It's not going to work. There's conflict of variable names, right? So to avoid that, one way to get around that is every time Peter uses a variable called x, he's going to say, I'm not going to call it just x, I'm going to call it Peter _x. And Susanna will call it Susanna _x. So there's two different variable names. The compiler will know two different things. Yes? So there's no conflict.
It makes sense. So STD can be anything, right?
STD could be anything. So STD stands for standard, and I think the designers of C++ said, we're going to define a namespace called standard, which gets automatically added on to everything that's defined inside of this namespace, right? So even if you define a global variable called x inside of that space, it'll be STD : x, right? It's inside of the namespace. So if they do that, right? So what they've done is pretty much given you a playground, a sandbox, inside which you can call variables like cout without saying, I want the cout which is inside of std, right? The compiler will automatically try the std prefix and see if that variable exists in that namespace, right? So for now, I think it is safe to ignore the details about, header files.
This makes sense, actually, the namespace.
Yeah, it makes total sense, but for now it is perfectly safe to ignore all of that. And because right now we just want the logic, right? We want to get the logic going and get people used to the idea that there are problems that can be iteratively solved by following a sequence of blind steps, right? Because in mathematics, you think about mathematics and you're doing proofs, most of the things, they're not iterative, right? They're closed form solutions. Bam, you get it like that. You derive and get. So the computer science, the problems you solve in computer science are algorithmic solutions, meaning that you don't get to the solution immediately in one step. There are a whole family of problems where you can solve it by solving it a little bit at a time, where each step gets you closer to the solution. Does that make sense? That is called an iterative solution.
Yeah.
Yeah, computer science makes that possible. And I don't know why we started. Yeah, logic, getting the logic right. That's more important. Right. So, all right. So let's get back to this code here. So run it now and oh, by the way, someone else was going to try this compiling this program without the parentheses. Did it work?
Yes, it did. I ran it at least in my compiler. It worked fine there. I don't know what Aaron got, but
it actually worked on mine as well. I'm surprised.
I was a little surprised as well.
Actually, yeah, I'm going to share my screen here for just a sec. I'll try this because I'm pretty sure that if I just go to a terminal, I'm just going to do a Mac terminal here. Hang on. So share my content. Where's my Zoom? Oh my gosh, where's my Zoom? Share content here. Okay, share. I want to share a terminal. Okay. All right. Let me try and share this. Okay, so let me go to, so I'm going to say, yeah. Can you guys see my screen?
Yes.
Basically doing exactly, I'm basically doing what, yeah, I'm doing what Peter just did, okay? Okay, now int a equals 10, comma b equals 15, right? By the way, instead of doing it in 2 lines, you can also do this. This is a short form, right? So you can comma, and then as long as all of the variables are of the same type, you can declare them on the same line. All right. Now I think I did standard colon cout sum equals a plus b. Okay. Let me see if this compiles here. Wow. I could have sworn that this did not work. Something like this did not work before. Because the reason I said that was because according to the PEMDAS rule, in my mind anyway, which was incorrect, right? Which was incorrect. This operator, the less than operator, had a very tight binding to it, meaning that when it saw this, it executed that first. Before doing a plus b, it did that. And then the result of that is a stream. And then I thought that, the compiler will complain that, hey, I don't know how to add cout. But by the way, when you send something to cout, what gets returned is also cout. That's the reason why and again, there's a long discussion about why that is. It's a very interesting discussion in a previous class, right? So someone please find it and, comment and mark it on YouTube for other people. But there is a very good and nice reason, right? That cout, when you send something to cout, it also returns cout. So it's a function, right? It returns cout. So that lets you chain these things. That's why it happens like that. And I was sure that this would not work. And so I'm glad to have found out, thanks to Peter's experiment. Okay. All right. So I'm going to stop my share so you guys can take your screen back. And,
I have a question really fast about your code. Is that you added std and then 2 colons before your cout.
That's because he didn't include. So, and I'll share my thing. If you do not have, and correct me if I'm wrong, but if you do not have this, then that's what you're going to need to do is every single time you make and it's 2 colons, I think.
Oh, no, not the int. You got it in the wrong place. Yeah.
Oh, is that good?
No, int is a native type. Only cout, endl. Those are the things that you need to.
Yeah, I thought you could put it on. You had to put it on int as well. Whatever. Clearly, I don't do it often, but basically for any cout or
endl.
Oh, in the endl. Thank you.
Put it in front of the int and compile it. Let's see if it goes. Put it in front of the int. I'm curious. I've never
try.
I think I got everything else.
Yeah. There's no int is a primitive type. It's not a. It's not a.
All right. Yeah. Oops. But yeah. And then because they didn't clear because they didn't recognize it.
Basically, anything that is kind of like does something. So like the NL will tell you to inline. So pretty much it will go in front of anything that's not declaring something.
Yeah.
No, not in front of anything. It's only in front of things that are in the standard namespace that you're using. And your question is, how do I know which ones are in the standard namespace? Yes. I think the way you find out is basically, let's say you want to use a library or a function and you Google for it, the documentation will tell you, right? The documentation will tell you whether it's a namespace standard or not. I'll show you, right? I'll show you. Actually, are you on a Mac or you're on a PC, right?
I'm on PC.
All right, just open another tab. Type in in your search bar. Type in man space vector. Man space vector C++ or something. Space C++. Yeah. All right. So click the first link. It'll tell you if you want to use vector. Vector is in the standard namespace. You see that std double colon in front of the vector? There. Yeah. You see that? So it'll tell you, and over a period of time, you'll find out what's in the standard namespace, what you can use, and what's not. You'll figure it out. But when you want to use something eventually, forget about vectors, right? You're not even getting to vectors until much later. But I'm saying that there are lots of things. Or just do endl, right? Google for endl. It'll tell you that endl is in, or cout or endl. It'll tell you that cout is in the standard namespace. There you go. So you'll find out what ones are in the namespace and what ones aren't. And what Peter did was, what I did was didn't have the using namespace, so that everywhere I used cout or endl, the compiler didn't know what they were. So I need to say to the compiler, hey, this cout is standard : cout. This endl is standard. So I need to say that. What Peter did was he didn't want the bother of doing that, because there's many places in which by typing in a standard : every time is a pain. So he says, I'm just going to use the standard namespace. He said that right at the top. So using standard namespace, if you say that, then what the compiler will do is, if it encounters a variable that is not defined, it'll look in the standard namespace to see if there is a version of that variable with standard prefix. If there is x in the standard namespace, it will look for a standard std : x, right, before giving up. Does that make sense?
This is all it gives you? Am I wrong?
Mm-hmm.
Okay.
Yeah, because that's just an object, right? These are objects, and it tells you what were you looking for here? What?
Oh, I was just looking at what an IOStream gives you. I think this is what I'm looking at, right?
Yeah, IOStream is basically just a header file. It's a file.
So when I say include, and I'm trying to understand a bit of it myself, when I say using namespace std, I'm calling into. Oops. No. I'm in a completely different thing. Ignore me. I'm on a completely different tangent.
No. Actually, in the URL bar, type this in. Type this in. Contents. No, in the URL bar.
Oh.
Contents of iostream.h. Contents of iostream.h. Yeah. Okay. Where did you get?
Is this?
Yeah. Click the Stack Overflow question. Click on one of the header. Yeah, you can actually see the contents of the file. I can show you, right? I mean, I got to share the screen again, but it's just a file. It's just a flat file. You can see it some other time, maybe.
I think where I was, maybe.
You have to look in the actual file. It's some you'll find.
I got it, but whatever. Whatever.
It'll be a massive file. It's a big ass file, like maybe 20,000 lines in it, right? Lots and lots of stuff. And you'll find that inside of that file, you'll have declarations for the left shift operator and, IOStream and cout and everything is in there. And hash include, what does a hash include say? Hash include basically says, here's this 3-line program that prints hello world. But before you even try and compile the program, here's another part of this program that need to include at the top, right? 20,000 lines included at the top. So
I think I found the IOStream file if you guys want to see it.
Yeah.
Sure. Where is it? I'm using the Visual Studio compiler, so it's gotta be somewhere.
You could probably throw it in chat.
Yeah, I think wherever there's different compiler versions of it. I have the GCC gnu.org one. I can't share my screen, but it's I can put the link in.
Sure, yeah, put it in, and then maybe Peter can click on it.
Yeah.
Putting the link in the chat.
You can take the screen too if you want.
Can you to anyone who has VS Code, I think you can highlight the IOStream and go to definition. I think if you go to your code and you highlight IOStream and then you go definition, you should see the file, right?
To do that. But.
Yeah, but anyway, that's let's not go down the path. It's just I think it's enough for us for now to know that IOStream is this big ass file somewhere, and then you're essentially riding on the shoulder of giants, right? Shoulders, like Newton said. Right? So you are leveraging everything that C++ designers have done for you already by building out the cout, cin, and all of those have been built for you. Those are your Lego pieces, right? And the 5 lines you wrote, and they are just tacked on to the end of an existing or large program. That's what the compiler actually compiles and runs. It compiles and then the runtime system runs. Does that make sense? Go back to your program now.
So that's why when you have an executable, for example, you don't have to include extra files like IOStream, right?
So when you get to the point where it's an executable file, there is no notion of included files or anything. An executable file only contains instructions directly intended for the CPU. Right? An executable file only has instructions like, you know, add these two memory locations together, move. It doesn't, there's no concept of files even. There's at the level of machine code, there's even no concept of files. It's just instructions to be executed.
Cool.
I don't know, maybe I ended up confusing you more.
But I meant, but I meant, you know, the step before, right? Before it gets to there.
No. In fact, include files disappear long before that. If we had time, I can show you. There's something called it's called CPP. It doesn't stand for C++. It's the name of a program, an ancient program called C preprocessor. All right. So you go to the tab, the other tab, and type man CPP. Man CPP.
This one?
Yeah, just type man CPP. Oh, not there. In the URL bar. In the URL bar. And now you're searching only C++, right? So man space CPP. Although Google can figure it out, but yeah,
Yep.
just click the one. It's called a preprocessor. Yeah, it's a preprocessor. And so the preprocessor is the one that looks at all of your, they're called preprocessors, anything that starts with the hash sign, hash include, hash define, hash, right? So the preprocessor directives, the preprocessor will read the include file and then read everything else under it, and then concatenate all of that together. And that is what it gives the compiler. So even though Peter wrote a 5-line program, the compiler does not see a 5-line program. That's something most of you didn't know, right? So even though Peter only wrote 5 lines, the compiler thinks Peter wrote 25,000 lines because iostream.h has 25,000 lines in it. So the preprocessor will take the 25,000 lines and then tack on the 5 lines of Peter at the end. So you got 25,005 lines. That is what the preprocessor will give the compiler. So the compiler never even sees your 5-line program. It sees a 25,005-line program. Does that make sense?
Yes.
Okay, so that's what the angle brackets include mean at the top. It means take that file, physically include that whole file in this file. That's what it means. Now, we can do that manually too, right? But if we do that manually, obviously, it's a bad idea, right? Because that file will be replicated on top of Peter's 5-line program, basically overshadowing it. Nobody will ever get to see the 5 lines of Peter.
And it would be unreadable, most people.
Unreadable, yeah. And also, you know, there's no use, right? It's the same thing over and over. So you just include that in a file and include the file.
That's, now I get why it's called include as well. It means, I thought it meant import, but they're sort of the same thing, but it really means, hey.
You know, import is also very similar, right? Import basically means, import means import the library that has been compiled into some kind of intermediate code or object code. Import the library.
It's like, hey, import these lines, right, into the compiled program.
No, import means import the routines, not include lexically. Include means lexically verbatim include. Import means it may not be verbatim, right? It may be compiled code.
Why? Oh, never mind. Sorry, if you want to continue. I just had a.
Real quick. Last thing, you mean like include puts in all the lines, right? Verbatim.
Yeah, include will put in all the lines. I can show you a demo at some point. I can show you a really quick demo. You want me to show you? Yeah, okay. All right.
I'm just making sure not to talk too much.
Actually, you know what? I won't show you a demo. If anybody wants, post a question on Reddit saying, hey, can someone show a demo of what happens with the, you know, hash include and C preprocessor? I'll create a 5-minute demo on YouTube, or someone can, right? Because someone asked a question about argc and argv for main, you know, command line parameters, a long time ago, 2 quarters ago. And rather than waste time talking about it in class, I did another short video and posted, which is there on our channel right now. It's a 5-minute video that shows you how to use argc and argv. I can do something similar for includes too later on. Does that make sense?
Yeah.
All right. So let's go back to your code, Peter. We still have some time, so let's do just some cosmetic tweaks before we make some more changes.
Okay.
So that we, compactify the program a bit. Hey, Peter, can you change all your declarations to be on one line? A equals 0.
Oh.
Yeah, B equals, yeah. And then you don't have the int after that because they're all ints, right? So you can get rid of the int, keyword.
I just have a question about the hashtag include.
Mm-hmm.
I understand why you might want to do that for kind of niche programs like with JavaScript or sorry, Node.js. You want to require it import some sort of npm library, but I feel like being able to print to a terminal is a pretty basic library. Why doesn't it just come pre-included? Why do you have to?
It does come included. That's
no, I mean, but like if you just did not have hashtag include IOStream.
Oh, I see. So your question is, I see. Why don't compilers automatically by default hash include IOStream, even if it's not explicitly spelled out? Why not have why not make everything know about? I don't know. I don't know if we want to go down. Good question. Good question. Who asked that, by the way?
Oh, that was me.
Me?
I'm Nate.
Or Nate. Sorry.
Nate. Oh, all right. Thank you.
Yeah.
That was a good question. And I don't know if we want to get into that right now. Many.
It seems like a lengthy question. I do know a small bit of that when I was creating my compiler. I know that I needed to, and every time I create a program for my compiler, at least, I need to declare to include the IOStream file into this program. I feel like if I needed to use a different library, I'd have to do that as well. I'll figure that out when I get there.
Well, I think Nate is asking, why not have IOStream given for free? Why?
Yeah.
Why do we need to explicitly include? I think
I don't know why it's not given for free, but I do know that I need to use it.
I'll tell you part of the reason, right? You can go researching because it'll take you a longer time. Part of the reason is because interacting with the user, input and output. Right now, as beginning programmers, maybe 50% or 90% of the programs you do interact with the user. Yeah, but as you become more deeper level, experienced programmers, you'll find that maybe even 5% of your programs you write will interact with the user. 95% of your code will actually be doing sophisticated processing in the backend, right? So you don't need IOStream there at all.
Wouldn't you still want to print some debug statements or anything like that? I mean,
that's at the time you're no, that's what I mean, right? So so these routines that you develop at the time you're developing, you'll have a separate main driver, and that main driver will have IOStream included in it. But your code that actually does the computation, right? Let's say you are there. Let's say that you are going to collect all the parking data from Foothill, the perimeter road, and you're running a massive machine learning job on Sage, right? So something like that in the back end. That's not going to interact with the user at all. So what's going to interact with the user is a main module, which is like 10, 15 lines, which will basically read a file or read the user input, send it to your other program, which is going to crunch it, get the numbers back all over the wire, right? And then the numbers will go to the screen. So what interacts with the user is just the 10,000 lines here. But the bulk of the job is actually being done by the 10 million lines here, right? So, and you don't need to have IOStream there. So that's part of the reason. You can go look up, and so all of those reasons weigh in on decisions as to whether what should be part of the language by default and what should be explicitly included by the user.
Makes sense.
Yeah. Okay. All right. So so that's been cleaned up, and you have the PEMDAS thing. All right. Now fix up the int x equals so that the expression. Oh no, you don't have to fix it up. You want to leave it there because you've got a comment there saying it's
not a bad example. Yeah.
So, yeah. Create a y. Create a y on the next line. Triple click on the line. Triple click on the line.
Oh, I'm going to.
Yeah. Triple click and then triple click on the line 29, 26.
26.
Yeah.
You want me to triple click here?
Yeah, triple click there. Command C and then copy that. Okay. Now go on to the end of that line. After the cout. Yeah, paste it again. Now make that y into y.
Yeah, I'm gonna put a. Oop. I'm gonna put a space.
Thank you. Yeah, I see. So what Peter just did was break that into a new programming paragraph. You know, programs are like English essays. They have paragraphs. You have to use blank lines between conceptually different tasks. Okay, so this is a new paragraph. Y equals, now do the correct version, right? Fixed expression.
I mean, I actually saw a comment in the chat that said a recommendation along that because it better shows what the relationship is happening.
But that's also not going to work, right? This is also misleading. Oh, I'm
Yeah.
sorry. Yeah. So what we want is A plus B times C plus D. So you want parentheses around the A plus B, and then parentheses around the C plus D.
That's what we want. Okay.
Yeah. So sorry, I didn't make that clear.
Yeah.
Okay. So this is not misleading. So this is what we want. So you can say, yeah, what we actually want.
Yeah.
So that is your PEMDAS rule in operation, and exponentiation, all these things that you'll find out eventually. So now you can print out the X and Y values. You can see that what they are. Oh, you are actually printing out X. You can print out Y too. And now and on the next line, this is right. We don't want to run it and waste time verifying it. Now let's calculate the average. Right? Calculate the mean. Does Peter want to do it, or does someone else wants to take a go? We have time for one more person, right? It's 9:48. We have 7 more minutes before the end of class. If one more person wants to take over from Peter, this link, and calculate the average of those 5 numbers and print it out, do it. No, let's do it with Peter, right? So Peter, calculate the average right there. Say int average equals. Now, this is going to be very important. Okay, don't drop off, guys. This is going to be very important. The last 5 minutes of the lecture is going to be very important. Okay, int average equals. No, average. No, not equals. Average.
Oh.
Yeah. Right. A plus B plus C plus D plus A plus B plus C. This is 4 or 5. Yeah, 5. A plus B plus C plus D plus E, and the whole thing divided by 5. Right. Now, is this a true average or not? So tell me, print it out, right? On the next line, see out. So triple click on the 20, put it there, and say, yeah. Actually, if you triple click, yeah, that's fine. Yeah, average equals, and then yeah,
it's an
average.
integer.
It's gonna come out as an int, right?
Yeah.
Yep.
Right now, print it out. Run it. I mean, I'm sorry. Run it. Okay, average 14. Is the average actually 14? No, it's not. It's not 14, right? So you can calculate it later. But in order to get the actual average, we're going to make a small change, right? So copy lines 32 and 33, right? Copy one more time. Paste it underneath. Yeah. Now, say instead of average, call it correct average, or accurate average, or whatever you want to call it.
That work?
Yeah, I say call it correct because we see people who are watching a video may not know. Right now,
Sorry, go on.
Yeah, correct it. All right.
Calculate.
Now you want to turn the 5 into a 5.0. Right? Turn the 5 into a 5.0, and then make the int correct average into a float or a double. Right? Now you'll get the correct average, because now the division happens. Now the division happens in floating point space, which does not ignore the fractional parts. Right? If you do the division in integer space, then the fractional part is gone, and you don't find the correct average. In order to find the correct average, you got to do it this way. Run it now, you'll see the correct average.
Oh, there we go.
Right? So 14.2. There's another way in which you can get the correct average. So copy those 2 lines and put them there on the same in the same program. Copy one more time. Right? Another way. Right? So put a comment saying another way on top. Yeah. Correct average too. Yeah.
Oh, yeah. I was like.
right? So here, what you want to do is just typecast one of those operands. Any one of those operands can be typecast to a double. Let's say take a B and make that a double, right? Oh, anything, you know, pick your choice. Pick one of those, make that a double, and you can make an integer a double by putting double in parentheses right in front of it. Okay, right.
That works?
Yeah, that works. So that means that B is now a double. Everything else is an integer. Now, what the compiler does when it sees that is that, hey, I'm adding all these things, but one of them is a double, which means that the result will also be a double, right? So that means I better make everything else a double too, because I don't want to lose the fractional parts of these A and right. So when any one of those is a double, everybody else gets promoted to a double too, right? Now, if you run that, you'll also get the same answer. Yeah, I think the right terminology is promotes. Yeah, all variables promoted to double by compiler because of B. Yeah, when one is a double.
Okay, I'm gonna have to make this up.
Right, and by the way, this only happens in this case where everything is on one line, and in some cases it may not, but we'll leave that, leave that for you to get bitten by and discover, okay? But this is usually the case. If you run it now, you'll still get the same answer because the expression, this got changed, right? So now everything will be double and you still get 14.2.
But it'll still chop off the fractional part if you had declared correct average 2 as an integer, correct?
Yes.
Or would it have promoted it as well?
Yes.
Okay.
Absolutely. In fact, try that, and the compiler should warn you. The compiler should warn you saying, hey, you're trying to take a double and trying to fit it in an integer, and the integer box is not big enough for a double. It's all the fractional components will be discarded, right? So if you run it now, the compiler should give you a warning. Why aren't you getting a warning? Let's go right to the.
I don't think I'm going to get a warning because everything works correctly.
No. You should still get a warning because you're taking a double quantity and putting it in an integer. I think the compiler here is running with without the warning flag set, right?
Probably.
Yeah.
A lot of online ones.
I use Visual C++ for it.
Even if it doesn't matter. It doesn't matter. They all invoke the same compiler in the back.
No, I'm just saying, I'm saying like mine invokes the warning.
Oh, you do get the warning. Okay. So this is a flag. This is a flag you have to set somewhere. I'm pretty sure in CPP.
Yeah, mine gives me a warning as well. It's just, I think that online compilers in general do not use.
No, they do. So just do a Control A here. Control A, go to cpp.sh. I'll show you really quickly. Just do a Control A, copy that, go to cpp.sh, paste it in. Control A, Control A, Control C. Control A, Control C. Go to your cpp.sh, the tab.
cpp.sh?
Yeah.
Oh, it's a shell one. Yeah.
Yeah. Now Control A, Control V to paste it. Control A, Control V. Okay. Now write down the 3 tabs there. You see, hit the compilation tab. Compilation tab. Yeah. No. Options. No. The first one. The first tab. Options tab. No. The first tab before the compilations. Okay. There. -W all. Is -W all clicked? Yeah, it is clicked, right?
Yes.
Yeah, click also -, W extra. Right. Now if you run it, I'm pretty sure it'll give you that warning. Okay. Run it, hit run.
There it is. It was hidden by.
Where is it? I don't see it.
I do not get an error.
No, hit the compilation tab. The middle tab.
Huh.
Oh, wow. All right, I don't know. We're out of time, but it's interesting, right? You got to figure it out. But my Xcode for sure. Just like.
Can you get me a URL? Can I try this on Visual C++? See if I get a warning.
Well, you can, but I think students are going to start dropping off. I'm okay. I'll stick around. Okay.
I will.
Save it.
Yeah.
I mean, because since I'll stick around.
Thank you. Bye-bye.
Bye. Was it Susanna?
Yeah.
All right. Bye.
Bye, Susanna.
Thank you.
Bye. Thank you.
Try it out on Visual Studio, and after this, we can call
And
it.
here for anybody who's
Hey, by the way, before
I
you guys
will-
disappear, before everybody else disappears, was this class useful? Did
Yes.
you get useful?
Yeah, definitely. Yeah.
Yeah. Let's get to go through the code together.
Main.cpp.
Can you give me the
Where'd it
link to the through C++ shell, so
Also,
I can test it on Visual. So I can copy and paste the code to my Visual C compiler. See if-
Yeah. Well, he's saying get URL. Go to the cpp.sh window, the tab.
Yeah, the fourth
right
one.
tab.
there also is a way to add flags to the online GDB that I just figured out. I can tell you guys.
I see. Okay, hit the get URL. Click get URL.
Get URL.
Yeah. All right, and then copy and paste that into chat because I think Nate was it Nate who wanted the URL?
No, Chad.
Chad. Okay.
Because I want to see if it shows up on Visual C if the warning.
Whatever.
Yeah, I just put it in chat.
Thank you.
Yeah.
Thanks. I'm going to try it. And
Yeah, I was following along with the whole demo. I really appreciate it.
Thank you. All right, I think people are starting to drop off now.
Just wanted to also say that mine compiled well, just fine with the double stint. Not sure why.
Wow.
Mine as well compiled fine.
All right.
We can. And I know with
new
the
at all,
online
right?
GDB, if people want to see that, try it there.
Yeah.
If you go up to that little gear.
Thomas, do you want to share? I think I'm going to go head out.
Well, I don't have that code.
Here's what we can do. Just do it, record it, and share it. Okay.
I can just share how to add the flags.
Share. Hey, why don't you share a YouTube video of this? Right. We'll just put it on the channel, and then people can see it too. How's that?
All right. If I have time.
Okay. All right. Yeah. Sure. Happy to watch it later.
Okay.
But I think people are dropping off. So thank you so much. So on Thursday, what we want to do is take this to the next level, right? So we'll try some more complicated expressions, and potentially also try playing with branching statements. Early stages of branching statements.
Yeah.
It'll be fun.
All right. Thank you. I'm gonna work on that video that you asked me to make for the compilers.
That'll be fantastic. And let me know, right? I need to add your email address to the list of YouTube managers, and then you can add your video there.
Yeah, certainly. Okay, thank you.
Thank you so much. Everybody, thank you for participating. I'll see you on Thursday.
Okay, bye-bye.
Bye.